Hey everybody. In this video we're going to go over some examples of whether or not subsets are subspaces. So, let's start with this example. We have W, which is a subset of three-dimensional space, and W just consists of all of the vectors that meet this specification. So, how do we check whether or not W is a subspace? Well, the first condition is that W is non-empty. In other words, the zero vector is an element of W. So is 0 in W? Let's take the 0 vector, 0, 0, 0, and we are simply asking, does it meet this specification? Because if it does meet that specification, then it is in W. So in this case, x would be equal to 0, y would be equal to 0. Clearly that meets the specification since x and y can be any number. And then if we take x plus y, this is simply going to be equal to 0 plus 0, since that's what those equal, and that is then equal to 0. In other words, yes, 0 is in W. Okay, since we have that figured out, let's go on to the next condition, which is that if we have two vectors that are in W and we add them together, then their sum should also be in W. So let's make up two. Let's just make up two vectors, for instance. We'll call one U, and we will call the other V. Let's make U equal to U1, U2, U1 plus U2. Let's make V equal to V1, V2, V1 plus V2. Now, we know that both U and V are obviously in W because they both satisfy that specification. That's what makes them in W. And now we're just asking, if we add them together, does that also then exist in W? So let's add them together. If we take U plus V, what we will end up getting is U1 plus U2, U2, and we are adding, we have V1, V2, and V1 plus V2. And just like before, we are just checking whether or not this satisfies the specification. If it does, then it is in W. So one way to see this is, let's just say this is equal to x, and let's say this is equal to y. And then we're just asking, does x plus y still satisfy or equal this? Okay? So let's take our x and let's take our y and add them together. Okay? Our x is simply going to be equal to this. So let's take u1 plus v1. And then y is equal to this. So let's take that. We'll take u2 plus v2. And if we do a little bit of rearranging, we can just take out both u's over here and put u2 plus v2 plus v1 plus v2. And then we see that this is clearly equal to that, and therefore we know that their sum is in W, and therefore these vectors, or W, is closed under vector addition. Okay? So there's that. Now let's go to the third condition. So the third condition is that if we take some scalar, we'll just call it C, and we multiply U, which is still in W, by C, then their product is going to also be in W. So let's take C times U. This will be equal to C, make some parentheses there. This will be equal to C times U1 plus U2, and U2. And this is then equal to C, 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 C. We're going to have U1, U1 plus U2, and U2. And now, does this satisfy the specification as well? Well, clearly it does, because if we allow x to equal that, and we allow y to equal that, then clearly this is going to be equal to x plus y. Therefore, W is closed under scalar multiplication, and since all three conditions are met, we say that W is a subspace of R3.